All right, welcome back, everybody. This is the Virtual Residency Workshop 2025. This is our 11th annual workshop. It's Thursday, June 26th, 2025. This is our first session of the day. It's explaining complex technical topics to researchers. Our moderator is Anna Klimaszewski-Patterson from Cal State Sacramento. And I'm going to turn the show over to Anna to introduce the panelists.
Hello, everyone. Thank you again for being up. For those of us on the West Coast, very early this morning, and for being here for the first session. As Henry said, my name's Anna Klimaszewski-Patterson. I'm going to be the moderator for the morning session. I just got promoted to full professor at California State University, Sacramento. So where many of you have been joking that you're failed academics and went into cyber infrastructure, I'm kind of coming at this from the other way. I was in the IT profession for over 20 years and decided to do something completely different. But everything needs computers. So I get to be that weird unicorn that gets to bridge the gap, which is why I'm really excited about moderating today's session on explaining complex topics to researchers. And so we're going to introduce our wonderful panel this morning. I'm going to have I'll call out everyone's name and then they can briefly introduce themselves, starting with David.
Good morning, everyone. My name is David Apostle from the University of North Dakota. I've been a research facilitator for 5 years, but I wear many hats under that title. I'm also a quarter-time instructor in computer science. I've come to research facilitation from a programming background, and that's been helpful in understanding the cluster, but it is challenging to communicate with people from other sciences. Thank you.
Oleg.
Hi everyone. Can you hear me? Hi everyone. My name is Oleg Starovoitov, and I'm working at Louisiana State University. I'm with HPC User Support Group specialists, and my background in computational chemistry slash material science. So all my life I've been doing molecular dynamic simulations and development of the force fields. And yes, as David mentioned, that it's difficult to communicate with other researchers from other fields. And the first thing we always meet is how mm, to understand the problem. So, and that's why I'm here, to share all experience. Thank you.
Thanks, Oleg. Zach?
Hello, everyone. My name is Zachary Gershner. I'm a high-performance computing facilitator at Clemson's Palmetto Supercomputer. My background is in genetics, microbiology, and biomedical data science, so I cover a rather broad swath of the molecular biology fields. I've done everything from software-defined networking to metabolomics and metagenomics, and been a research facilitator for about 2 years now, and I specialize in supporting those bioinformatics workflows. And so when I'm having to interact with other users outside of those domains, finding ways to communicate what needs to be communicated can be a little challenging. So I'm here to share my experience with that.
Thank you. Prentice?
Hi, I'm Prentice Bisbal. I'm currently an HPC Systems Engineer 3 at the NSF National Center for Atmospheric Research. I've been working in high performance computing for over 25 years now. My background is actually chemical engineering, and I think that's been very helpful to me because, that kind of covers most of the sciences that I deal with. So I find that it helps me be able to speak to all of my different users and know some of their own language, and I think that helps me relate to them. And I've most of my career been a one-man shop, so I do everything from system admin to dealing with users. So this is something I've got a lot of experience with.
Thank you. Manasvita?
Hello, everyone. This is Manaswita. I'm currently at the Faculty of Arts and Science Research Computing team at Howard University. I have roughly 5 years experience in the research computing domain. And prior to that, I was in high energy astrophysics. That's essentially my background in numerical modeling. And I think that is also the reason that I was able to transition to this domain because the experience I had as a user of a supercomputing facility, I really helped me in kind of making that transition, and is continuing to help me bridge the gap between a user and a facilitator. And that's why I'm here. Thank you.
Thank you. And then Lee Wen.
Anyway, you're muted.
Lee Wenshi, Computer Engineering at University of Houston Clear Lake by Johnson Space Center in Houston. And so I'm a professor. Major is the computer architecture and AI. And recently I've been teaching courses in quantum AI HPC. So my students been saying I'm brilliant in explaining complex things like superposition and stuff. So I think hopefully I can contribute today. So my career coincides with supercomputing. So when the supercomputing conference is celebrating 35 years, I'm working 35 years. So this is my 37th years. So nice to meet everybody. Hopefully I can answer some questions.
Wonderful. Thank you, everyone. So we'll start off with the first question, and I will ask it of Lee Wen, but then anyone else can chime in. So Lee Wen, what is the most challenging aspect of your interaction with users when explaining complex and/or technical issues?
I think everybody is very siloed in your own field. So I think the most important thing is for engineer, especially when my students or my researchers trying to explain something, most of the things they don't see missing in the communicating through the presentation or write-up are the things that they have in their head. So it's like when an artist, you have to kind of look your product from a distance to pretend you're not an expert. So for the good engineer and good scientists, often that you do not see what's missing in communicating. Also, they are like, one time I heard like in business people, they were saying hands off approach. I was like, oh, is that a joke? Because in computer engineering, we only talk about hands-on. So I think this is very different. So I took digital medical data on the medical center. Houston has the biggest medical center in the world. So the professor Dean, he was saying that sometimes he would talk to the doctor and tell doctor, there's something computer won't do. And then talk to the computer, oh, there's something doctors won't do. So we do need to communicate with the same terminology. And also we are often, so number one, engineer and expert, they are lacking, they're overtrained, and they are lacking understanding of why people don't understand. Number two, we are all in our own area. It's our own definition, our own terminology. So it's hard to communicate. So these are the situation that is causing difficult. So I often told my student, I have no problem with quantum physics, but Einstein has, because Einstein was overtrained by the classical mechanics. So so I think we just need to kind of like when I asked DeepSeek, I say describe pyramid as a 3 years old, or describe pyramid as an Egyptian. So we all have different explanation that we have to be audience oriented.
To build on that, I think the biggest thing that I face with interacting with users on complex issues is identifying the common ground, where to really start your explanation of that complex or technical issue. Because a lot of these users have either exceptional understanding of the domain expertise question that they're trying to ask of the data and are struggling with the technical aspect, or vice versa, where they have an incredible understanding of the technical, but are struggling to interpret the technical because they're struggling with the domain um, question. So identifying the gap between those and building your explanation from the ground up from a starting point where you both can agree on is critical. So it builds on what you were saying in that not understanding what needs to be communicated and identifying where that starting point is probably the most difficult thing that I've experienced is
So when you're looking for that common ground, out of curiosity, are you using analogies in order to kind of try to get people to frame things in a different way to be able to see what those connections might be?
I do use analogies, but I also use a modified Socratic method, for lack of a better description, where it's more probing what they understand about the issue and then identifying, okay, well, they understood, for example, in biology, they understood that they're trying to get this transcript expression out of this data set, but they don't understand the different tools that are available to get there. Um, so that allows me to identify that their technical expertise needs some improvement, but they have a clear understanding of what they're trying to deliver. And then I start building analogies from that point to kind of fill that gap. So I use a little bit of both.
If I can jump in here, I use analogies all the time. And I like to use things that are very simple that people can visualize because one of the problems with computers is you can't see how they work, right? Look at look at Zach's background. You just see a bunch of grills on the front of a computer. You could stare at that all day and not know what's going on inside that computer, right? So I always like to use very simple, very basic analogies that anybody can grasp. I'll just give you one simple example. One thing I always argue about um, is that clusters aren't being used efficiently, right? Some of my positions in the past, we had users that didn't want to learn how to parallelize stuff, and they were just running, using the cluster for serial jobs. That was, a waste of their time. Forget about the waste of the cluster. It's a waste of time if you're paying an employee to wait all month for results from a job that could be done in a couple of hours if they parallelized it. So my example would be, say you're a pool company and your job is to install pools, right? So first you got to dig the holes to put the pool in. So the boss goes out and he buys an excavator for like, a few $100,000. But the workers don't want to be bothered learning how to use it. So they're just using shovels, right? That's not a good business model. But when you tell people about the excavator, that's something that they've all seen work and they can visualize. And then you talk about guys using shovels rather than using the backhoe. Like everybody kind of laughs when I use that example, but then they get it because it's something that's very easy to visualize and they get it. And, that doesn't really cover when you're talking to a user, but that's an analogy I like to use a lot because it's something that's simple and everybody can grasp it. Like, kind of another example I like to think of and don't use as much is like parallelism. Yeah, like imagine people making pizzas, right? You can have one guy making it. I'm from New Jersey, so we incorporate pizzas into every conversation, right? So you have, you know, imagine one guy making one pizza at a time, right? That's not a very good model. So you get a big pizza place, now you got to hire three or four people. Like if it gets busy, you got to hire three or four people to make all the different pizzas, right? And then that kind of demonstrates parallelism. But then if you want to get into the more complicated stuff like single instruction, multiple data kind of stuff, you could talk about them making pizzas with different toppings, right? And that would be the different data, right? So one guy's making a pizza with pepperoni, one guy's making a pizza with meatballs, one guy's making a pizza with, God forbid, anchovies on it, right? Or even worse, ham and pineapple, right? So, yeah,
Okay,
Anna.
let me add, so for SIMD, I just say you just follow the Zumba teacher, right? And
Mhm.
then for the whatever, the other one you just use the orchestra, right? So everybody play different music, or processor play different program, or every processor lockstep. So I use the orchestra and the Zumba.
But yeah, I always try to think of the simplest analogy and something that everybody can visualize. At least in this country, everybody's walked into a pizza place and has seen a guy making a pizza. You know what I
Mhm.
mean? Like, so I try to use stuff like that that everybody has seen, that everybody's familiar with, and most importantly, something they can visualize.
And from
So one
starting
time,
out, oh, go
I'm
ahead.
sorry. Okay, one time my student just trying to explain hyperthreading, and when you go to read about hyperthreading, it's all commercial. They don't even tell you what exactly is going on. So I suffered through like half an hour explanation. So I said, "Are you talking about two people try to cook in the same kitchen?" So all of a sudden, everybody understood.
Yeah, the
Yeah.
double from my early experience, analogies were also kind of a double-edged sword. I had a lot of users who were from outside of the country who hadn't experienced a lot of things that we've experienced. And so I made certain analogies that, like when I was explaining data flowing through a pixie stick, like when you have a pixie stick and you're pouring the sugar out, your data is flowing from one end of the pipe to the other. And they were like, "What's a pixie stick?" So it took me a while and some coaching to really kind of identify which analogies were good to use, but it took a little bit of trial and error to get that nailed down.
And that's a perfect segue both into our next question and then also the question that David Young asked in chat. So David Young's question was, at what point is the only effective way to communicate using pictures, diagrams, and flowcharts? But scaling that out a bit, how do you navigate conversations with your users? And let's go ahead and start with David.
Um, well, I start off by letting people know I don't really know your science, but I'm very good at using the cluster. And if I start explaining something that is where I'm using jargon or terms you don't understand, I ask them, please stop me and don't let me get too far down the road. Let me explain or rephrase so that I can keep the person with me. At the same time, um, I'm kind of saying that I may need your help in understanding some of your jargon. Uh, that's how I kind of start things off when I don't know people's background. Well, typically I know their science, but I don't know what their this is kind of the first meeting how I start things off. Try to let people know that I'm not an expert in their area and I will help them use my our cluster as best as I can.
Yeah, so adding to what David said, that is essentially similar technique is that I also apply in most cases. People who come to us have varied background. They could be from quantitative social science or applied sciences, applied physics, some of the scientific domain that they are working in may be familiar to us, but may not be. So the premise is always it's always good to put that premise right in the beginning that either we have not dealt with this before, or it's better if we break it down into pieces so that we can help them figure out how to best implement it on the cluster. Because at the end of the day, that is the main goal, to make sure that a workflow is optimized for the cluster. But sort of circling back into the first question, because I feel it is related when you are facilitating a research. um, I find that it is pretty challenging to kind of follow through. So, for example, if someone comes to you with a complex problem, or let's say, this is a fresh grad student, you were explaining how to use Slurm job arrays efficiently on the cluster or how to do parallelization, and this is just your first meeting and you have no idea if that follow-up is ever going to happen, even though you have offered. And that is another challenge that I have not been able to solve, even though and I think I want to say universal. It doesn't matter which university you are working at, that kind of a tendency of not being able to follow through because of so many other reasons kind of puts a restriction in how much we can facilitate. So I think that would be another challenge, at least for me. If it can be solved, I'll be really happy.
I agree with that 100%. And the way that I normally tackle that is when I can tell that this particular explanation is going to take more than one session or it needs a follow through, I'll schedule that appointment right during that session. And then I'll CC their PI so that their PI is aware that we're still having this discussion. And then when it comes the week before, I'll send them a reminder email saying, hey, just a reminder, we had this appointment to follow up to finish explaining what we were talking about. Because when I'm navigating these complex issues, I ask one question to start, and that is, are you facing a deadline? If they're facing a critical deadline, I try to provide them the immediate answer and say, let's schedule an appointment to follow up on why we did what we did. If they're not facing a deadline, I'll take the time to actually do the Socratic method and empower them in discovering what the solution should be. Um, but that takes time and usually multiple sessions. But it's something that I'm finding that users are really appreciative of because they feel like they had more say in what they did in their research rather than just being told do X, Y, Z and it will run. So I find that approach to be very effective. Have you guys seen something similar or?
I agree, Zachary, with you. So we do similar things. We do follow up. We do multiple sessions. The most challenging, of course, as Manasvita mentioned, that it's try to understand the complex uh, problem and environment of this problem and how can we implement it on HPC. So, and yes, we often ask if you have a deadline. If they do have deadline, we're trying to put as much uh, efforts as possible before the deadline. But if they don't, we usually take some time to let's say to work it out more and try to test it. So we do actually tests ourselves on the problem and see if it works and see if we understand it correctly and see if we can parallelize it, for example.
Mhm.
So, yep, similar, very similar.
Awesome.
Okay,
What
so
about
some
navigating, quick question. What about navigating conversations where you think that you understand what the other person is saying because it's the same word, but in every discipline, different word, same word means different things. So like scale, right? Or code. Code can mean programming, code can mean the ID, scale can mean a spatial extent, it can mean the resolution of a cell, it can mean up how much of something you have. How are you navigating potentially some of those kinds of difficulties within those conversations?
Well, like in everyday conversation, you have to look for context clues and try to go with that. I generally try to avoid technical terms whenever I can because I assume the other person may not know that. Um, but yeah, that certainly is an issue once in a while. But I often ask if I think somebody's using a term incorrectly or there's a misunderstanding, I'll generally ask more basic questions to try to like root out if we're talking about the same thing. I can't think of any good examples right now, but sometimes I'll say like, okay, when you say this, do you mean this? And I'll often say, because in my world, that term means something else, or that term could mean something else. So I don't want them to make them think that I think that, I say that because I don't want them to think that I think they're an idiot and have no mastery of the English language. You know what I mean? Um, and so I try to say, okay, when you say this, do you mean this? Like to make it clear that I'm trying to clear something up. Now, since I just mentioned like the English language, native languages of people is also a problem, right? Um, a lot of research, like America's got some of the best research universities, infrastructure, right? Rather than just any individual university. So we have a very international user base that almost all of us are dealing with, right? Certainly on the East Coast where I live, it's incredibly diverse. And I'm sure it's like that around most of the research universities of the country. And that can be another problem too, is just dealing with cultural differences and language differences. But that's how I solve it. I'll say, when you say this, do you mean this? Or, I just want to be clear because that term can be used multiple ways. And I'm very overt about trying to solve any kind of communication issues.
So, a lot of my consultation sessions are full of words like, or questions like, did I understand this right? Or do you understand what I'm saying? Or is this what you meant? And a lot of times, let's say if I'm trying to tell them to do a simple test on trying to figure out if their code is actually scaling well with adding more number of cores, let's say. So after I explain them, this is what they should try to do, I always follow it up like, so did that make sense? Can you tell me if that's okay? Just to kind of get that confirmation that they have understood what I'm trying to explain to them and vice versa. So yeah.
So
And
just to lighten things up, in English, it's very difficult. So I remember some headlines just for fun here. So when Walmart gets so big, it becoming a target. And there's another one says Iraqi heads seek arms. So heads means the ruler or the leader, and then arms is the firearm. So it's very funny. Yeah. So earlier I was just trying to say, yeah, some explanation need to be in picture. Like when I'm talking about topology of the cluster, factory, and talk about tofu, torus fusion, and Hilbert curve when the slum trying to schedule the processors, sub network. If I don't show picture, it's kind of hard to explain the topology. So some problem does. And when I try to do like AI, machine learning, when I look at the space and trying to find the higher accuracy is when the border is tighter. So if I can show it with the diagram, it's much easier to explain.
The other thing that I encounter when trying to navigate this is identifying just how much information to share in the first session, because at a certain point, it's like drinking from a fire hose, and your user or your grad student you can just see their eyes glaze over at a certain point, and you're like, okay, I've said too much, or we've deviated from where they've understood, so we need to backtrack and understand um, how to get back on track. Um, One trick that I've really found useful in identifying just how much information needs to be shared is that common ground. Once I figure out where that common ground is, I segment the things into like 30-minute windows, if how much information should be fit into a 30-minute window. And then that's what I give in the initial contact. And then the second contact, I'm take it to 45 minutes. And then if there needs to be a third one, I'll take it to an hour. Slowly building up their tolerance to the amount of information that needs to be shared, as well as giving them digestible chunks to work with.
so following up on the being able to find that common ground and the using of analogies and the vagaries of the English language, is there anything that you have said or done that felt embarrassing, and how did you recover? Oleg, would you like to start with that one?
I will try. Yeah, I was trying to remember if I did something. Maybe if I said a mistake, or um, I'm not exactly sure. But how to recover? You just take time. You just take time and trying to think through and see what you've done wrong, and then follow up with the user and trying to explain again in different terms or different manner. So, but uh, I don't remember exactly um, what kind of embarrassing thing would I say? No, I try to be uh, diplomatic, let's say, and polite, and very patient, actually, very patient. Yep.
I definitely have one that I could share. Um, I was working with a new biology student who had inherited a script from a person from a different cluster, and so we were trying to clean it up so it would run on ours because it was built for a PBS based cluster, and we had just transitioned to Slurm, so we had to go through and clean up some things as well as change all the modules that they had listed and all that. We go through all of that, and it's still not working, and we go down this hour-long troubleshooting session and I say, okay, where did you finally ask, where did you get this file? And it turns out that that hour-long troubleshooting where we were progressively not going anywhere, turns out that the issue was that they were copying everything from a Word document to the script. So it all had the /r/n.
Yeah.
And I just sat there and I was like, I now know what the problem is. So we're going to quickly fix that. And sure enough, the script ran perfectly as soon as we addressed that issue. So I had to explain to them. I turned it into a learning opportunity where I was able to explain to them what the /r/n/n was and what they were doing that was causing the problem. So they've not since converted to like Notepad plus plus for if they're actually writing their code out in like a lab notebook format. I'm trying to get them to switch to Nextflow, but that's down the line. So
Yeah, that had happened to me in some of the earlier training sessions where we'll run it and then people will try to copy the commands either from our PowerPoint slide deck or something, and it'll always introduce those funny characters. So we started putting out text files so that that takes it. But in terms of one incident that stands out to me, that was a little embarrassing for me was I think a ticket came in and the way I understood, I ended up pointing the user to a Slurm job array, like a sample script that we had, and only to realize right after that was that I had completely misunderstood the problem. So then I just, asked the person to come and meet me instead because that would be just easier. I just said, hey, by the way, I'm sorry. I think it was I misunderstood. So how about we have a one-on-one session so that you can explain the problem to me, in person and then just go from there. So yeah, that's how I handle that. But it has happened a couple of times, nothing drastic. But whenever something like this happens, I always follow it up in an email or via ticket that how about we have a one-on-one session so that it's easier to resolve.
So I would say I've never been embarrassed by anything I've done because I've got a very high threshold for embarrassment. But getting back to what Zach said, I would say the facepalm moments, right, is when you're dealing with a customer user and you find out it's something very basic, like having a file with carriage return line feeds rather than new lines. And you spent like a week or even months trying to debug a problem. And then you find out that it's something super simple that you just assumed nobody would do but you're assuming with your knowledge, right? You're like, well, no computer scientist would do that, or somebody, like anybody who's familiar with computers would know that's a bad thing to do. So you just assumed and never asked that question, right? Remember I said about like asking obvious things to clarify. Sometimes there's things that seem so simple and obvious you don't even think that's never going to be an issue. So why would I even ask the user that? And so those things happen, but then you have to be careful not to create an embarrassing situation because now you have to be like, you know, I didn't ask about that because I figured that was okay, and now you have to put that in a way where you're not insulting the user, because basically the undertone of that is I figured you'd be smart enough to know that that's a problem. But it's really you just don't have enough knowledge in this area. But yeah, there's been several times I've worked on problems for days, weeks, maybe even months, and it was something almost as simple as what Zach said, carriage return line feeds instead of just a new line. Real simple, obvious stuff that you're like, well, that's too simple and too obvious to be the problem. Like the user would have like pointed that out already or whatever. And it happens. And like I said, not embarrassed, but you're just like, oh,
Another fun one I had, um, I was troubleshooting a script for a metagenomic pipeline running Chime. Um, and everything looked right. Everything looked correct. And then as I'm scrolling through on my home computer, which has a larger monitor, I notice that there's not an underscore in one of the file names. They put a space in the file name so that when the script was trying to run, it kept trying to execute that as a flag. And I spent a good 2.5 weeks troubleshooting that
Oh,
just
no.
to find just that they had put the space in. Um, so again, turn that into a teaching opportunity of in Linux, you can't do that. You need underscores if you want to put a space or something or a hyphen. So a lot my career is full of those little things where it's just like, oh, I made an assumption that should not have been made. But it's been great. It's definitely helped grow my experience and in facilitating, and it also really gives me something to joke with the users about. Because when we make that communal understanding of we both made a silly mistake and we can laugh about it, they are more willing to come back because they see you more as a person, less as an administrator.
So Zach, then would you like to take the lead off on the next question? Because I think you're kind of hitting in there. How has explaining complex and technical issues to users enriched your life experience?
It has enriched it in many ways. It's forced me to have a better understanding of the different aspects of the field that I work in a way that I can communicate it so that it's not overly technical, it's not overly jargon filled. It also has enriched my way of approaching explaining other things to people. So in my hobbies, in my day-to-day activities, when I'm trying to explain what I do, because before I used to be very technical, very this is what I do, very precise. Now I give the more general gist, and if they ask, I drill down a little bit at a time so they can follow through. So I definitely think that it has been very rewarding to do that.
I can add to that. So, as I said, prior to research computing domain, I was in astrophysics, just doing my own research, happy with whatever was happening there. But switching to research computing and interacting with so many users, sort of like opened my eyes and ears to a whole new different world, which is different from how astrophysics behaves or works. I had to get comfortable with software installation, which was very different from what I had done as a grad student or a postdoc in astrophysics. And even beyond that, building containers, so all of it. Not only that, one of the things which I felt personally proud of was I was helping a group with slum job arrays, and it was not a simple thing because they had some few 100,000 runs that they wanted to process, and then the way they were doing it could have taken them more than a year to do it on the cluster. So I was able to put a recursive script together, which would call, whatever processing had to be done using the Slurm job arrays. And all of that was really within the first year of my starting a research computing facilitator job. So that was really a big learning moment for me. And all that was just from trying to interact with users, trying to help them out. So I really felt very good about that.
I think a good session with a client can make me feel great for the rest of the day. but it's a two-edged sword because if I have an awkward or unproductive session with a client, I can feel lousy for the rest of the day. It's really the how the client perceives the value of our session affects me considerably. I can't just put it behind me and go on to the next one. I carry that with me, whether good or bad.
From my side, I would like to add that basically when you solve the problems, you build in your head some particular number of steps that you will perform in order to get a result. And that helps not only for HPC, for solving problems for users, but in your own life too. So that's what. So you've been thinking like, okay, what's the right method? What's the right way to do that? What's the right way to tackle the problem? How can I get the result? Yeah, am I on the right track? So all these things are helping in your real world too.
Do you guys find that the more that you interact with the domain scientists, the more you see connections between those domains that maybe those scientists don't do, or the more you see the exact same issue coming up, even though it's in a completely different context, but fundamentally it's the same?
Absolutely. And I have been working extensively in the last 6 months to try to link these researchers together through the core facilities on our campus as a mediator, because it gives them a point of contact in terms of something that they understand or respect, and then that other user can come in, and then the core facility can facilitate that discussion. Because sometimes I have found that trying to connect Professor One to Professor Two directly through myself doesn't usually result in a collaboration. It's usually, oh, that's interesting, and then they move on. But if you get the core facility involved, then they see a opportunity for a grander collaboration and a potentially a larger grant opportunity, um, and they're more willing to start having those dialogues. Um, at least that's been my experience in that regard.
Yeah, I would say the same that it's, for example, we have a quantitative social science group that we interact with from time to time. And recently they had the need to put their workflow that required distributed GPU computing. And I already knew there was another group that was doing that. So I just, had to put them in touch so that they can essentially learn from each other. And, the social science group can actually see how some of the distributed GPU computing examples have been implemented on the cluster. So a lot of times, having knowledge of some of these groups, what they're doing, kind of helps us also in facilitation. We don't have to reinvent the wheel every time.
Mhm. We've
We
also tried implementing a Mattermost server to help these researchers talk to each other with asynchronously without us being directly involved. And we've had mixed results in adoptions. Some areas are really interested in using it to collaborate with each other, and then others are more siloed and less wanted to communicate. So I was wondering if you guys had tried different approaches to facilitate those discussions.
I mean, if you ask me, I think for us, we so far we haven't tried an approach like that. It's mostly through us or us interacting in some form or another. It doesn't have to be in an active form, but just knowing that, hey, this is the research that this group is doing, and they can potentially be helped by the other group, is something that we try to do. Um, I think in terms of having that kind of an approach, one thing to be careful about is sometimes the group, even though they are domain experts, may not fully understand how that can be implemented on the cluster. So I think if a research computing team is involved in some capacity or the other, I think it will help both the groups in the longer run. So as of now, that is how we have tried to navigate the situation.
For me, when I've seen an issue with one group, I haven't had an experience where I've been able to use that and help a different group. But what I have been able to do is see problems from two different groups and relay that to our system admins and say, this is what we could do different, and it would make things smoother for most of our users. So I tend to bring that since we're a small shop, I can talk with our sysadmins just with a Teams message or
Yeah,
submit.
from
Sorry,
Go ahead.
I was going to say or submit a ticket and then discuss that ticket the next time we have a meeting.
Yeah, for me, I see most of the users struggling with the same problems, no matter what group they're in. But I'm also not like a high-level consultant doing like RSC type work, right? I am primarily a system admin, and my issues are mostly like usability type stuff. Uh, what I benefit from seeing other groups work together is if somebody's using a library for the first time, I'll often know if another group is using that same library. And since, most of the places didn't have like RSCs on staff, I could say, well, I'm not a programmer myself or not a skilled programmer, but I know that this other group is using the same library. Here's one of the developers that's using it. Why don't you reach out to him and he can probably give you some guidance. And that is always very helpful, being able to just refer users to each other.
So problem solving is universal. So I think we all encounter similar issues trying to resolve some problem. For myself, I think I attend training and I conferences and I host all these monthly trainings from Access. And so when people come to the meeting for a particular machine learning or whatever, then they start to talk to each other. When I attend the user forum for quantum and Los Alamo people was talking about all these different jobs running on their quantum computer, then they connect me to a project that in Berkeley Lab that's similar to what I'm doing. So because of that, I was able to connect to people in Berkeley Lab and Oak Ridge National Lab, workflow people, because I'm trying to do is to, for example, I can make the Cyber Shake run 1/3 faster just simply by placing the job in a compact shape. So that will minimize the traffic for the system and reduce the time and call hours charge for the users. So as a computer engineer, we want to optimize and solve problems, and we need all kind of problems from all different disciplines because we have the rocket, we have the fastest car, but if we don't have the application, we don't have data, then we don't have any place to go.
So it kind of sounds like the ability to be able to do all of the problem solving, which is what inherently everybody's wanting to do, and the opportunities to help facilitate not just you're facilitating somebody, but helping facilitate those interactions across people is very rewarding for everyone's personal lives as well as their professional ones. Manasvita, if you'd be willing to take the next question, because I think you're the most recent, if I'm remembering correctly, to the CI portion, having come over from astrophysics. How helpful are your past experiences in explaining complex and or technical issues?
Yeah, I think plenty. So as a user, when I was in academia, I was just focused on getting my research work done, right? It didn't matter to me how I'm implementing it on the cluster as long as I get that done. And I had no idea about the other side, like how the back end is operating to make that happen. So when I made the transition, it just blew my mind in terms of the complex nature of supercomputing world. And I think this is probably one platform or one domain that bring in so many people from so many backgrounds to just make research happen. So that really gave me the clarity on how I can approach users coming from that background, that'll help them implement their workflow on the cluster. And, as I already mentioned, the first thing is really trying to help them break down their problem so that you can try to help them piece by piece, right? It's not possible for any one of us to kind of have the whole thing implemented right away. So I think just playing user versus facilitator in the back of my mind helps me in talking to them and trying to tell them, okay, let's do it step by step, and then see if that helps get what you want from the cluster. Another thing that I started thinking, or I try to implement and probably even communicate to our users, is we need to really treat the cluster as a virtual laboratory. So that is something which no user realizes ever, because I realized it as a user, right? Like when I was a high school student, I would go into chemistry lab or biology lab. We would always follow a lab protocol because that's the physical laboratory you're entering. But when you are on a cluster, you don't realize it that it's a virtual laboratory because you're running your experiments and you forget to follow the protocols, which then leads you to many issues that could have easily been avoided. So that is the other piece that I kind of started realizing, that this is something that should be communicated to all our users when we are facilitating, that treat it as a lab.
I 100% agree. When I'm working with users, I often remind them that, especially if I'm interacting with a grad student, of common mistakes that I made as a grad student on the HPC system, and why I tell them about things like Nextflow or SnakeMake, where you can encapsulate a lot of the variables that you'll be asked about later in your defense. It's already there captured in your code. You just have to pop it open real quick and check your note, and it's right there. So following that laboratory procedure or building those laboratory procedures absolutely is critical. So my experiences in grad school and undergrad research drastically changed the way that I approach my facilitation.
I agree with Manasvita and Zakari. The same. When you're a graduate student, you do all these mistakes, and now when you interact with the graduate students, you can see what they do in absolutely the same mistakes. And based on your experience, you try to suggest that, okay, so before, for example, running a series of molecular dynamic simulations, you need to make few tests and see if it works. So you don't waste time. You don't just submit a job and sitting and waiting for your results. You constantly need to monitor that. You need to do all the analysis before the job ends. So it's not like you started the job and sitting, getting the results and be done. No, no, no. You constantly need to work out and see what's going on with your system. And definitely you need to check all the parameters. Is it those parameters, etc. So all those kind of tiny details that you missed when you were a graduate student, you basically try to help them out. Yeah.
And not to forget a simple thing as clean up after yourself. Once you're done, make
That
sure,
that's true. That's true.
right? Like, so yes, so that is something as a user never hit me, but now that I'm on the other side, I'm like, no, we need to communicate this better to our users.
Lee-Wen, you have the most experience doing facilitation. What would you say? How has your experience, has your past experiences helped?
Um, I've been I think I was a number 5 campus champion in Texas or something like that. Anyway, so I think a lot it's becoming very difficult. I think for example, now you have this composable hardware, you have container, you have all those kind of things. Now for computer engineering, it's already hard enough. Uh, So they say you have a computation. So how much GPU do you want? How many SU you want and what kind, right? It's very difficult, and that's why I'm trying to automate the process. I'm trying to optimize and automate. And also, there's a lot of opportunity for us to minimize. And then, of course, the entire supercomputing, we are very. So I was in Fugaku, Japan, Rikon Center, and I said, well, how can I help you, Dr. Satoshi-san? I said, how can I help you design the Fugaku next? And they're scratching the head because it's a $1 billion computer and $40 million electricity per year. So how much can you go further, right? So I think we are all in a dilemma of, how to optimize it. And every user have this different computation and what is the best way to allocate your job. So that is really hard. So I'm trying to automate, like, first you have a workflow and how do you partition into multi-worker? Then how do you connect your sub network so that you are compact? And I use like load imbalance instead of load balance. So, and then after that, how do you place your job into the cluster so that you don't have fragmentation of this piece, that piece, and then you are wondering why it took so long because there were a lot of hidden hops that you don't even know as a user. In the future, the same thing, when the quantum computer, you also have to place job on the multiple chips when you scale up. So it's quite challenging. And then, of course, everybody is so good in their domain, and then we'll have to find a way so that we can and you cannot do this by yourself. That's why we are here together. We crowd learn and all that, and communication is important, not just for the to the machine, and also for AI. How do you word it? So for the communication, it's almost like a database search. Every single word you are narrowing down, and then guide the listener to where you are trying to find. Okay, so if you can reduce your if you query in such a sequence, and you can reduce your target faster. You can go from you find the richest person in the world, let's say, from 10 billion people to Fortune 500 CEO. Then you reduce from 10 billion to 500 instead of 10 billion to, let's say, all the male, businessmen. So from, if you just by gender, you go from 10 billion to 5 billion. But if you go for population to Fortune 500, you go from 10 billion to 500. So there's a lot of room for optimization so that we can make supercomputer more sustainable. And then in the meantime, we have so many choices to the point that in the future, the machine and AI can tailor to your need in your application. And that tailoring is really hard because if I ask you, what do you want? And you have to know what you want. So it's becoming very challenging, but I think together is making it easier. So I appreciate this kind of, yeah. So like game of life. So I was speaking at South Africa. So I have a lot of international, and I have another one in India. So anyway, so when I was finishing my keynote speech at the South Africa CHPC, I was like, we're a game of life, If you are only one person doing quantum AI, then you die. But you have like 2, 3 friends that to do the same HPC, then you become alive again. But then you don't have one or too many, right? Too many, then you like too much competition. So I think, there's a lot of challenge. That's why we need to like stick together, and then we have to keep growing, which is good for our brain, right?
And that's a perfect segue to our last question, which kind of helps sum everything up. And Prentice, if you'd like to take the lead on this one. Are there any specific recommendations for how to prepare for making recommendations to users that involve explaining complex and or technical issues?
Okay, so going back to what I said before, right? I think the best way to explain complex technical, anything complex, is to break it down to something as simple as possible and use analogies that everybody can relate to. And very important, use common language. I've never been a fan of jargon, and using very complicated terms when you don't have to. Like one of my big complaints is when you ever watch the police giving a press briefing, they got to use big terms, perpetrator, we apprehended him, it's like just say the suspect and you arrested him, like don't use big terms if you don't need to. It really, I think it works to your detriment because it makes it look like you're trying to overcompensate in some way. And simple terms are better. They just work better. I mean, yes, there are some times where you have to use a complicated term because it is the only word that really fits. But a lot of times I think people use complicated language when they don't need to, and I'm not going to dive into the psychology of that. I'm sure other people can, but try to use simple terms that are common to every discipline. You know, uh, like for example, when I talk to users the first time, I'll often bring up my background. That my background is chemical engineering, because that kind of says, well, if you're a chemist, they can use chemistry terms and I'll understand it. If they talk about differential equations, I'll understand that. If there's somebody that does fluid mechanics, I'll point out that chemical engineers um, know fluid mechanics, so that if there's somebody that use Navier-Stokes equations and they're talking about that and solving systems of differential equations use Navier-Stokes, then they can use that terminology with me. But so when you have that, when you establish common ground, yes, you can use more technical terminology. But generally, if you're having these conversations, it's because they don't know understand something about computers. You don't understand something about what they're doing. So always try to use the least common denominator, the lowest level language that everybody's going to understand and works. Don't use domain specific language. I guess if you want to use our lingo, don't use domain specific language when you're talking to a customer, right? And like I said, using the backhoe analogy versus shovels and wheelbarrows, those are something that everybody probably will understand, stuff like that. Making a pizza. Okay, pizzas are pretty universal. Everywhere I've gone in the world, they sell pizza. That's another common thing that people wouldn't understand. So always try to break down complex things into something simple that most people could understand. Like on Reddit, there's the Explain Like I'm Five subreddit. You know, I don't care if somebody's got a PhD, a Nobel Prize, a Fields Medal, unless it's for computing, there's a good chance they may not understand computing because that's not their area of expertise. So break it down for them. But of course, you don't want to you don't want to make it sound like you're condescending when you're speaking to them. And I don't think it's hard to use simple terms without sounding condescending. So that's my advice. Simple analogies, things that can be visualized, and use simple language.
I'd
Yeah,
like to,
yeah, go ahead.
thanks. I'd like to put in a plug for the virtual residency workshops. I've been coming to these ever since I started in research computing, and I always come away with something um, like today, treat the cluster as a virtual lab. I love that. Um, Also, the Cyber Ambassador program is very helpful in helping me communicate with people from different backgrounds. I took the Cyber Ambassador program 3 or 4 years ago from the Colbys at Michigan State, and I wish I could go back and take it again. Now I see that there's so much to be gained from that. So that kind of training and talking about technical things is what works for me. It helps me.
The one thing that I would say in preparing to explain complex topics or technical issues is make sure you come in with an open mind when you're going into that explanation, because when you go in with your single solution or single route in mind and you're explaining it and the user doesn't quite get it, you get thrown off your groove, you get thrown off your explanation, and it makes you stutter, it makes you stumble. But if you come in with an open mind, you can adapt, you can be a little bit more expressive to that user in that situation that you find yourself in at that time. So it makes it seem that you're not trying to pigeonhole them into a solution. You're more trying to explain the overall concept. You're trying to explain why this is the recommended approach. Um, and if it doesn't work for that user, then you continue to have that conversation about what they need. So keeping that open mind is, I believe, very, very important when you're approaching that issue.
Yep. Related to that and being open-minded is sometimes the solution that you have, or what seems like the obvious solution, they're in some sort of corner case that that solution doesn't work that you haven't thought about yet. And there have been many of times I'm like, well, you just need to do it this way. And then a user just comes up with like, well, we tried that and it doesn't work because of this. And it's either something unique to their problem or it's sometimes a legitimate bug in the software they're using, whether it's a scheduler or something else they're using. So yeah, you got to keep an open mind about how you communicate them and what the problem really is. You know, the whole if every problem looks like a nail, or no, if your only tool is a hammer, every problem looks like a nail kind of thing.
I agree with Prentice, actually, in terms of communication, but I also, so the question is, speaks for itself. So how to prepare? So very often, um, I think that, oh, my explanations are good, but when I listen someone else with better, way better explanations, I'm definitely learning how to explain the complex thing in a very simple manner. So whether I see it on YouTube or in online or from someone else, so I'm still learning and I'm trying to explain this complex problem to myself first, and then like, does it sound understandable? Is it easy to understand? Do I like? So I'm asking myself. Plus, nowadays, definitely it's very helpful, the chat GPT. So, if I think that I know something, I always refer and see how ChatGPT explains this problem, for example. Uh, and I'm checking myself if I miss anything, uh, maybe something else I can add. And basically, training yourself will I mean will facilitate, and I will be becoming better explaining some complex stuff. So, but yeah.
So, and building up on what everyone has already said, I typically just go with the mindset that we are here to solve the problem together. I'm not solving it for them, or so I'm rather trying to teach them to fish for themselves. So that I find it helpful that if I go with that mindset that we are trying to solve the problem together, it takes the edge off me. And also, I think it helps them communicate to me more comfortably. So that kind of is the mostly the go-to mindset that I have whenever I'm in a consultation session or trying to figure out an issue or debug an issue, either via ticket or in other form. But going with that open mind is probably the key for me.
I would
I
just
really
say
like,
one thing don't do is like my calculus professor. My calculus professor, whenever I ask question, he would just say, "Oh, it's obvious." So that's one thing not to do.
well, thank you, everyone. I think those were some really excellent points, especially there at the end with the don't talk down to people and say it's obvious. Obviously, it's not because they're not understanding it. Um, and the coming at it as a we are approaching this together and it is a collaboration, not I'm the person who has all the answers and then if something doesn't go right, it's your fault, not theirs. And then also the ability to communicate and break things down into the smallest possible pieces. So that way, these overwhelming challenges now feel much more approachable, both for yourselves and for the researchers that are being facilitated. I think we are at roughly about time, unless anybody has anything short that they would like to add. Otherwise, I will hand that over to Henry.
All right. Thank you so much, panel, and a round of virtual applause. Thank you all. And I keep saying the same thing because it keeps being true. We can tell that this was a very engaging session for our facilitators, for our audience, because they wouldn't shut up in the chat. They're having a grand time, having a wonderful conversation. And I think we're all learning from each other. It's absolutely terrific. So I want to thank you, everyone, for a great session. I'm going to stop the recording